Hi guys and welcome back to the channel. Today we got another fix for my video series. This time we got this FNIRSI 1014D digital storage oscilloscope. Now it seems that I got a problem with it when I try to turn it on. The screen is white apparently. This is due because at one point I have to drop it and sadly the screen doesn't work no more. I discovered that this morning while I was working on my axial flux generator, and sadly when it was time to check some waveform on it using the oscilloscope, I got this problem. So this I think it will be perhaps a quick fix or a hard fix. Let's see. First of all, this oscilloscope I bought it like few years ago, and since then has been working wonderful, despite that is saying it's 100 megahertz 1 gigasample oscilloscope, but in reality it's less than that. Now let's take it apart to see how can I fix it by first unscrewing the 4 screws at the bottom, and then from what I see I got 3 more on top. Now I remove the back cover, remove the power plug, and here we are inside the oscilloscope. Looking quite interesting, I may say. And here we got the ribbon cable for the display, and from the looks of it, doesn't look like it has been disconnected, but let's just unplug it and then put it back. Maybe it's just a connector issue. Like I said, I have dropped it while I was renovating my shed. We're getting the power plug from the case like so, and trying once again to power it. It's got a nice function. This oscilloscope is quite nice as it's working on 5 volts, which makes it portable, and that's a great plus for this oscilloscope. Sadly, it seems to work, but not great. We got some flickering lines. I don't think it's the connector. I tried to press it on it. I think I just got a busted screen. Well, that's quite inconvenient. From a slight drop, the screen got damaged. It's not physically damaged, it's just internal damage. Well, I think I may go and get a replacement for it. Meanwhile, let's taking it apart further by disconnecting first the ribbon cable and then remove all the buttons from it, making sure they will be going back in the same order. Alright, like so. And all the screws will be going here, as the screw likes to fly away, and then it's just a matter of unscrewing lots of screws. And now with all the screws out, we can remove the PCB from the case. Here we have it. The PCB is looking nice though. It seems that we got a F1C 100S micro CPU, which is I think 32 bits, and I think this chip, which is 0173030434496, I think it's a ADC, so what is doing the communication, and these two I think it's a ADC perhaps, and under these two shield metal cases are the what is isolating the two connectors from the chip which is doing the communication. What I see here is some plastic. Wow, I never been opened this oscilloscope before, but it seems that the PCB looks interesting. Regarding the soldering job, it's quite bad. I mean, on the SMD parts looks interesting, but on the THD components it's quite awful. Anyway, it's not that the problem I have to deal now. It's the screen. Let's place the PCB here and remove these rubber pads, and we got another 6 screws to free up the LCD from the case. Well, the 6 screws are out. Now let's remove the screen. It just comes out. That's interesting. And here we got the screen. It doesn't look like the screen connector is damaged, but let's check something. Let's add the screen back to the oscilloscope like so, and connect the small ribbon cable and clip down the connector, and then we'll be getting back the power. Let's switch it on like so. Maybe it's a problem with the cable. Apparently it's looking like a problem on this side of the connector, the ribbon cable which is connecting to the display assembly, as it's trying to output something, but the cable is no physical damage. I think the inner connection of the display are broken. As you can see, if I press it slightly, it's doing something random. So I think it's due to the shock of it. Like I say, I have dropped it, has developed some inner structural damage. Now let's just switch it off. So I remove the cable, the display cable, like so, and as well the power cable. Something to mention, it seems that the entire memory of this oscilloscope is on this SD card. That's interesting. And we got a 8 GB micro SD card, which is holding the software of this oscilloscope. Now regarding the display, what I can do is just to search for a replacement, as I may afraid I tried to take it apart, so attempt to fix it will be not great, I may say. Well, it's coming apart quite easily. That's something you don't see every day. And we have the backlight is still soldered. Extra piece on the ribbon cable, and from what I see, I don't see any structural damage on the cable. And like I say, I think it's just some internal structural damage. Well, I will be attempting to fix it at one point, but till then, as I need this oscilloscope, I will just be getting a replacement. So we need a 50PEE554E. Now after searching this serial number on the internet, I have come across a replacement for this oscilloscope. After a while, I got the replacement for it. Hopefully, the screen will work. It is the same universal screen, 800 by 480 pixels, 7-inch TFT display. And let's see. Well, it's nice package. That's a good sign. Let's get it out of the way. And here we have it. Nicely wrapped. Now let's see if it's working as a replacement. Let's get the PCB, install it same fashion as the old one, just to check if it's working or not before assemble the entire oscilloscope. The flex cable feels a bit softer than the original one. That is something I have noticed. Now let's get back the power cable. Let's turn it on using a screwdriver. Seems to be working perfectly now. I think we just have to put it back. First we install the display. Got this screen protector. So rather than just peeling the small tape from it and keep the protector on the screen, I know it doesn't look okay, but for me it's perfect as it is. I just need it to work. The screen back in its place. It's just a matter to put everything back. First starting with the extra rubber piece for the buttons. Routed this ribbon cable through this cut on the PCB. So then we just add back all the screws to the PCB. Now remembering when putting back screws in plastic, it's better to go a bit anti-clockwise till you find the thread, and then clockwise. Like that you prevent the screw digging a new thread in the plastic. Then we can add the screws for the LCD. After all the screws are being installed, we just install the ribbon cable. Let's not forget the power connector. Not forget to connect it. Then we just close it all out. Then the oscilloscope fully assembled. We just add the buttons back and we are done. Now let's test it. And it seems to be working like normal once again. Now regarding the old screen, I think I will be attempting to fix it to have it as a spare, but we will see how the new screen it will handle. Well, this was a quick fix anyway. And now let's try something else by connecting an audio signal to the oscilloscope. I found a clip which is generating some waveforms on the oscilloscope. It's from Jerobin Pedersen cycle. And as you can see, the oscilloscope is working now wonderful. It will be great that I can go ahead and I'm finishing taking the required measurement. So I hope I will see you all in my next video. Till then, have a nice day and thank you very much for watching. See ya.